friends, welcome back. Now without wasting much time, okay, as I did in my last videos and all, right, straight away we'll just go back to the business, right. So today I have brought two things. I have brought two syntheses, right, the way sympathomimetics can be synthesized, right, and which are kept in PCI syllabus as well. So the first one that I am going to deal with is phenylephrine. The phenylephrine, okay, we talked about phenylephrine while dealing with SAR, right, in my past videos and all. So let us see that how this phenylephrine can be made. Phenylephrine, right? Okay. So phenylephrine, from our previous understanding, we know that yes, phenylephrine is a drug which is basically targeting alpha receptor, right? Alpha 1 to be more precise, right? And how alpha 1 selectivity grows because on removal of this parahydroxyl from this entire aryl alkanol amine, okay, template, right? The moment you are just removing parahydroxyl, the drug has acquired, okay, a tendency to choose the alpha 1 receptor, right? Therefore, an alpha 1 stimulation leads to vasoconstriction, right? It can be given as a nasal decongestant, right? It is out of its vasoconstrictive effect. So an alpha 1, we all know that most of the alpha 1, okay, agonists, right, out of their this vasoconstrictive effect and all, they can at least provide us the decongestion or decongestive effect. So that is why in nasal, as a nasal decongestant, this can be given, right? So it's a vasoconstrictor, can be given for the purpose of nasal decongestion, right? Sure. So now let us see that phenylephrine. First and foremost, the way the strategy which I am adapting, right, or rather I have been or the strategy which I used to adapt, right, in my college days and all, okay, that is first and foremost you have to see that how the blueprint looks like, the blueprint, because phenylephrine, you can just simulate it into a normal life and all. So it is nothing but, the drugs are nothing but a construction, right? A construction, a molecular construction, right? Like a building, right? So first and foremost, the planner should provide us the blueprint, right? Say now the thing is that after that we are just deploying certain we are just deploying certain troops and all, or the mechanics and all, so that the mechanic can see the blueprint and start the construction, right? Chalo. So now the thing is that, so phenylephrine, so first and foremost you need to see the structure of phenylephrine. So phenylephrine, so phenyl is there, okay, so phenyl is there, we have a beta hydroxy, okay, so beta hydroxy, and we have a amine, and that is a secondary amine, so like this, and there is no para-hydroxy. If there is no para-hydroxy, definitely you can find some selectivity towards alpha 1 receptor, right? And that is why phenylephrine is an example of alpha 1 adrenergic agonist, right? So now this is the structure, right? Now let us see that how this can be constructed, right? So this is the building, and we know that a building can be constructed with the help of raw materials, right? So here the raw materials should be the starting materials or the intermediates, right? Okay. So how do you decide that yes, this is the building which can be constructed with the help of bricks which are made out of mud, or this is the building which needs to be constructed not with the help of bricks but with the help of a stone, right? Okay. So that means there should be a criteria for the selection of the raw materials, right? Okay. So first and foremost, and a building is constructed with the help of raw materials. Out of their union only a building is constructed, right? So with the help of a favorable interaction and union only a building is constructed. Same thing has to be applied here also. The same concept has to be applied here also. So now that means once the structure is there with you, now you need to see that the area which is susceptible towards the breaking and all. Now you need to break the construction and start finding the kind of fragments, and start finding the starting materials on the basis of the fragments which are emerged out of this breaking process. What I mean to say is, अब इसको कहाँ से हम तोड़ सकते हैं? So this is the area which can be broken. Got my point? This is the area which can also be broken, and this is the other thing. So this is the first unit, this is the second unit, and this is the third unit, right? So we have with us 3 fragments, right? Now we need to see how these fragments can be assembled so that finally we can get the structure of phenylephrine, right? So this is found to be the fragments. So fragments 1, 2 and 3. Now let me tell you one thing. So what should be there? Suppose we have with us the fragments, but when we are running the synthesis, we should not take the fragment as a starting material. Rather, we should complete the fragment into a possible starting material, right? So now the thing is that, so here it is CH3NH. We all know that it should be a methylamine. It should be a methylamine. Why? Because the hydrogen can be replaced in the process of inserting this portion to a particular entity. One hydrogen has to be replaced. So that means it should be a secondary amine. Sorry, it should be a primary amine, not secondary, because CH3NH2, earlier it was secondary. So one fragment that we have completed, we have given a possible shape to a particular fragment, that is fragment number 3, and that is nothing but methylamine. So we have got one of the fragment, that is methylamine. Now the next one, like this. Now we need to see, so here we are using the hydrogen for the removal purpose, right? The hydrogen should leave along with an electronegative atom, and that is coming from the second fragment. So electronegative atom. So what should be the electronegative atom which can be attached to this? The electronegative atom should be an halogen, right? So that means we can expect and halogen can be a part of this fragment. It used to be a part of this fragment, right? Now it is in assembled state. Now we have just fragmented it. Okay, it has been fragmented, right? And we are dealing with this second fragment, right? Now as we have seen that the immediate neighbor of this amine is found to be CH2. So that means the CH2 should provide the electronegative atom to this hydrogen so that they can readily eliminate it, leaving behind the CH2NH portion. So that means probably the CH2 is having an X. It's connected to an X, right? Now let us see the CHOH. You might have noticed that if a carbonyl group is there in a starting material, and if our purpose is to convert the carbonyl into a hydroxyl, usually with the help of this reduction we can readily execute the process, right? So that means C double bond O can be readily reduced. Why I am telling these things? Because when the C double bond O, because I need to attach the C double bond O with this phenyl. So that is why the CHOH is found to be the less, I should not say it should be the primary choice. The primary choice should be a carbonyl one, and that too attached with an halogen, another halogen, so that it can be readily punched. It can be readily, fixed to this particular carbon, right? So that means in the process of merging this carbon with this phenyl carbon, so it's better to convert the CHOH into a C double bond O, and subsequently an additional halogen should be incorporated to the same carbon, right? So that the halogen and hydrogen should leaving behind the C double bond O with phenyl. And we know that how to convert the C double bond O into a CHOH, right? Simply by reduction, and we have n number of reducing agent, right? Okay, तो चलो एक चीज मिल गया हमको. The second fragment can appear in the form of like this: halogen, C double bond O, then CH2, another halogen, right? Okay. The third one is like this. It should be kept as like this, phenol. Okay. अब देखना है, can we cuddle down the steps? So if we just take these 3 reagents at a time, we cannot throw all the reagents in a reaction vessel, right? If that is the case, we are just making a recipe for disaster. Finally we'll get a terry mass, right? A terry mass you can get, right? Okay. Because in normal conventional synthesis, this cannot be happened. In UGI reaction, multi-component UGI reaction, solution phase combinatorial chemistry, this can be done, right? But in conventional synthesis, the one which we are doing in our mundane labs and all, this cannot be done. Throwing all the reagents into a particular reactor and expecting that it should give us this kind of thing, it's not. It's utter nonsense, right? Okay. Chalo. So now the thing is that phenol can be the third option. So the third fragment can be a phenol, right? Now, Now what I am thinking, the company people, they are asking us to just curtail down the expenditure. That means they are asking us indirectly to just remove one of the step. So what should be done? That means we should find an intermediate between this and that. This and that. Can they be merged and take as and considered as and taking and considered for the starting material? For the step 1, can they be merged? Can we take the merged component as a starting material? Yes, that can also be possible. So that means all you need to take is the phenol along with this C double bond O, no longer the X, and CH to X, right? Okay, chalo. So now with that we are done with the collection. We are done with the development, right? So we have developed what? We have developed few fragments out of this structure, and we have just reshaped them so that we have got the starting materials which are likely to be incorporated for the making of phenylephrine. What are those? So the first one is a phenol. A phenol, as I have decided to just curtail the expenditure and all, okay, because we are in the COVID-19 stage, right? So that is why expenditure cannot be incurred by the company. High expenditure cannot be incurred by the company, right? Okay, so all we have decided to just merge it, right? C double bond O, then CH2, then Cl. Okay? Okay? So this is the thing. Okay? So this is found to be the starting material. This is found to be one of the starting material, right? So this is the first one, the first starting material, right? Okay. So how this can be named? So this is basically acetyl, right? So what we can say, the alpha this carbon can be considered as alpha carbon, right? Well, because C double bond O, the next neighbor, alpha. So alpha is holding what? Chloro. So alpha chloro acetyl phenol. Okay? Alpha chloro acetyl phenol, right? Okay. Or in other words, to be more chemically authentic and all, so basically as it's a phenol, so 1 2 3 3, which is holding within bracket alpha chloro or 2 chloro acetyl, then close the bracket and to the phenol. So this should be the starting material, right? Next, to this starting material, we need to merge what? Amine. The amine is straightway methylamine. We have already collected, okay, we have already shaped the methylamino portion into a methylamine. So likewise, methylamine. I have just written it for your for the convenience of presentation and all, right? Okay. So just merge them all together, react them all together. There is removal of HCl, and what we have got? We have got, on removal of this HCl, we have got something like this. So what is next in the process? The next in the process is what? Is a reduction. So you can take like a any reducing agent like lithium aluminum hydride, LiAlH4, right? Lithium aluminum hydride, right? One problem arises here. What is that problem? The problem is the moment you are reducing C double bond O, definitely this will get reduced, right? But what will happen? Earlier there was a pro-chiral center. The pro-chiral center has been converted to a chiral center, right? So now there is a chirality develops, right? And it is out of chirality, it will appear in the form of an enantiomer. But we are not after recommending a patient with the racemic mixture. We have to resolve. That means we have to find out a resolving agent, okay, which can isolate the isomer which we are after. As the reduction causes the generation of a chiral center, so as a result of it, the same phenylephrine we have got, but that appears in the form of an enantiomer, a pair of enantiomer. We are not expecting to deal with both the forms, right? Rather, we are expecting to isolate the one that is found to be biologically significant. Got my point? So, biologically significant one. How this can be, separated? That means we need to find out a resolving agent. Resolving agent. Okay. How do you select the resolving agent? Actually, the thing is that, see, if the compound is basic in nature. If the compound is basic in nature, we are using an acid. right? So that there is a formation of a salt, right? And the moment there is a formation of a salt, a diastereomer is formed. And the diastereomer can be readily separated. Got my point? So diastereomers are not found to be racemic mixture, right? So what the primary intention is, as there is the presence of an amine, that is the secondary amine has to react with the resolving agent, which is basically has to be chosen on the basis of the basicity of the starting material. So here the compound is found to be basic. So that is why you have to choose the resolving agent which is found to be acidic in nature, so that there is a formation of a salt, and the salt will appear in the form of a diastereomer, and the diastereomer can be readily separated. Got my point? So here we have to take another resolving agent. So here we are taking the resolving agent as camphor in sulfonate. What does it mean? If you just try to shape it, camphor in sulfonate. So we are done with the making of this phenylephrine, right? So camphor in sulfonate. So what does it mean? It's a good resolving agent for the one which is for the one which possesses basic inmate agent, right? Okay. So camphor, it is something like this. As I told, camphor in sulfonate. So this is found to be the camphor portion, right? And this is the methane sulfonate. Got my point? So here we are using resolving agent as a basic one, as an acidic one, right? This acid will react with this base, so that there is a formation of a salt, and the salt is nothing but not the racemic mixture, rather the diastereomers that can be readily separated. So this is the way by which we can generate, or we can develop, we can synthesize phenylephrine. Got my point? Thank you. So now let us deal with the next one, that is salbutamol, right? Salbutamol, the making of salbutamol. Salbutamol. We know how to, figure out the structure, right? Or how to construct the structure in the board, right? Salbutamol, that means salicyl alcohol. So salicyl alcohol is something like this. HO, H2C, then HO again, then your same thing like beta hydroxy. Then we have another CH2, then NH, and we know salbutamol is an example of a beta agonist, right? Beta 2 agonist can be given in bronchospasm as well as COPD, chronic obstructive pulmonary disorder, right? Chalo. So now NH, and what should be there? Butafol. Here it should not be misleading one, a tertiary butyl, right? Chalo, a tertiary butyl. Okay. So this is your salbutamol. So how this can be made now? Now, let's see how this can be made, right? So here, let us just, first split the entire structure into possible fragments as usual. Then we'll just try to, reshape or try to give each and every fragment a shape so that they can be effectively taken for the synthesis, right? Chalo. So here, first one is this portion. This is the portion. And then, okay, we can take this one as well. Okay. Then this is the portion, right? Okay. So likewise, this one, here, we'll just take a different strategy, right? So here, we'll just protect the amino, right? Protect the amino. It's not NH2. So we'll just protect it in the form of like this. CH2 phenyl. So it is N-benzyl. At the end of the show or at the verge of completion, we'll just deprotect it. It is for the proper reaction to flow. We'll just protect the N terminal of this tertiary butyl with a benzyl group. We have a debenzylating agent as like a palladium on carbon catalyst. Usually it is meant for hydrogenation, right? If a particular benzene is found to be in the form of cyclohexane, so it's better to take this PDC, right? Or sometimes in the process of making naphthalene also we are taking these things like PDC, palladium on carbon catalyst, or palladized charcoal, sometimes we are calling it as, right? So palladized charcoal is having an application in the field of debenzylation or deprotection as well, right? Okay. So this is we got the first first reagent, right? I should not say it should be the starting material, right? It may be an intermediate or it can come in the next step, right? It may not appear in the first step, but it can come in the subsequent steps as well, right? Chalo. So this is the one, that means N-benzyl tertiary butyl amine, the one amongst, okay, one amongst the all, right? Chalo. So now this is the thing, the earlier thing, in case of phenylephrine, what we found, yes, we got the strategy. That means if there is an ethanol type of things, then it's better to make it like this, a carbonylated one, right? CO, CH2, then Br, and we'll put here Cl, right? So we have with us what? Bromoacetyl chloride. It is the alpha carbon that is holding what? Bromo, alpha bromoacetyl. So this one is acetyl and chloride, right? So alpha halogenated acyl halide, right? Okay. So this we got, because this is the thing that this concept we got from our earlier synthesis, right? Okay. So this we got. The second fragment has been transformed into another reagent, right? Another reagent. Now coming to this, we have a salicyl alcohol. Straightway we are not using salicyl alcohol. Instead, we know that if it is something like methyl salicylate, okay, chalo, H3C, C double bond O and then O. If it is found to be methyl salicylate, this can be reduced as well. This can be reduced as well, right? It can be reduced into CH2OH because it is the ester, right? That can be reduced to an alcohol. I am not telling that we are reducing alcohol to form an acid, form an ester. It's not possible, right? But rather, if we just stick to this, if we just try to knock this ester, this can be readily reduced to an alcohol, right? And the reducing agent here we are using like these things like lithium aluminum hydride, sodium borohydride, NaBH4 as well. So we have got now with that we have got the various reagents or the various significant reagents, okay, which are likely to be incorporated in making salbutamol, right? Now we'll see one after another that how and in which state they will be brought, right? Okay. So first we'll bring the methyl salicylate, okay. So let us just bring the methyl step 1. I'm talking about step 1. In the step 1, we'll just bring methyl salicylate, right? Okay, methyl salicylate. Okay. So methyl salicylate. I just want to react it with this, as I said, that alpha halo acyl halide. So here we'll just use Cl, then C double bond O, then CH2, then Br. I strongly suggest that whether भले ही आप intermediate का नाम लिखो या ना लिखो, but you should write the name of the starting material. This just carry an weightage to the evaluator, right? Okay. So evaluator will start thinking, yes, the person should know. Yes, the person not should know. The person knows well the chemistry and all, right? Don't write the chemistry paper as a person of arts, right? Okay. Simply mugging up and just vomiting out each and everything. It's not. You are not supposed to vomit out or supposed to expel the bug, okay, into the paper, right? Okay. Chalo. So now this is your alpha halo. So alpha is holding what? Alpha is holding bromo. So alpha bromo acetyl, then chloride, right? Okay. Yes, there should be a reaction. This one is very corrosive, right? This one is very corrosive for your understanding and all. So what will happen? What can be expected? The expected is, yes, Cl will leave, I, Br, ClF, I, Br, ClF. Electronegativity is more, right? And moreover, yes, chloro by virtue of its electronegativity analysis, bromo is there, but if we just try to figure out the periodic table, it says that chloro is found to be more electronegative than bromo. It's not like this, it's like this, right? So that is why Cl. So Cl will first join itself, right? So we are done. Next, what will come? We have to merge here tertiary butyl. As I told that here, we'll just straightway we are not going to incorporate what tertiary butyl amine. Instead, the amine which we are going to bring, it should be protected with a benzyl moiety. So that is why the one that I am going to bring here is tertiary butyl N-benzyl tertiary butyl amine. So N-benzyl. So I'll just yes, N-benzyl means CH2 phenyl. This is benzyl. Then tertiary butyl. Tertiary butyl amine, right? What can be expected? This will definitely join with this, right? So joining will take place, right? Now, it has been joined, right? So we have got something like this. Now, what is left in the process? The left in the process is we need to reduce it. We need to reduce what? We need to reduce this as well as this. We need to reduce this because this should not be in the form of C double bond O. This can be reduced to CHOH. So that is why the same reducing agent like lithium aluminum hydride, right? It can reduce this. In the next step, we just bring lithium aluminum hydride. This will just convert the C double bond O into OH, and subsequently this will get converted to HOH2C. Got my point? HOH2C. Now what is left? As I told, debenzylation. Once we'll just free this particular end, what will happen? We'll get the structure of salbutamol, right? Chalo. So now what next? The next is debenzylation, and as I told you, the agent that should be brought here is PDC. PDC for debenzylation. Usually the PDC can be used for hydrogenation. You can find in the literature, right? But here we'll just use it for the purpose of debenzylation or deprotection, right? Chalo. Once we'll just apply PDC, what will happen? The CH2PH will leave this point, right? Leave this point, leaving behind what? Hydrogenation as well as deprotection. So PDC meant for hydrogenation. Okay. Once the benzyl has been left, what will happen? It has to be hydrogenated. So both the purpose can be solved, right? So now with that we are done with what? With that we are done with the structure of salbutamol. Like this. Got my point? So now we have with us salicyl alcohol, we have with us CHOH, CH2, and we have with us tertiary butyl amine. So this is the way we should write the synthesis of what? Salbutamol. So with that I'm done with salbutamol. Thank you for your kind patience, okay, and all. Thank you very much. If you do like this video, please don't forget to press the like button, because at this particular point, I'm a bit shaky. I don't know why, because every time I feel that while asking you to press the like button, I often get confused, right? But I should not, right? If you like this video, press the like button, but that should be in an unbiased way. And one more thing, please do subscribe my channel so that you can readily come to know that come to know about the update of my videos and all, right? So you can keep yourself updated with my videos and all once you subscribe my channel. So thank you so very much for your kind patience. Thank you.